BA or AB, according to the diagram, is perpendicular to OE, which means for this part, you use the original theorem 1. Line from center, perpendicular to chord. Okay? You don't have to write that. Line from center, perpendicular to chord. You stop there. Okay? That's based on the examination guidelines. I told you about the examination guidelines in terms of the acceptable reason. Right? So, for this, because the 90-degree angle is there. The 90-degree angle is there. If the 90-degree angle is there, then you use the original theorem 1. Yes? I can't hear you. No. Right? Because of this, you use the original theorem 1. Okay? I'm talking about for this side where you've got AB. Now, because of this bisection, for CD, because of that, you use the converse. Okay? Be careful tomorrow because you can write the reason for the converse when it's the other one. Okay? Make sure you're aware of this. Okay? If the 90-degree angle is there, then you say line from center perpendicular to chord. If there is a bisection of a chord by a line from the center, okay, then you say line from center to midpoint of chord. Make sure you know the difference. Okay? Right. To midpoint of chord for this for CD. FD is equal to FC because of line from center to midpoint of chord. Okay, so let's do the question now. So 8.21 says calculate the length of OD. This is point O, that's D. Okay? Which means for me to get OD, I'm going to need to use CD. Which means I have to use the converse of theorem 1. Okay? Now, based on the question, can you keep quiet? I'm talking to myself. Keep quiet. Right, this is your CD. It's 8 centimeters. Now, before you go anywhere, if you want to determine this length here, you need to know that this angle here is not 90 degrees until you use the converse of theorem 1. Okay? So, the best way is to start by saying here, FC is equal to what? FD is here. Okay? You can say it's given, but I don't want to say it's given. I'm going to say, okay, let me write it down here. I'm going to say FCF is equal to FD. The reason for this is because of the converse. Line from center to midpoint of chord. Okay? Midpoint of chord. Okay? Now, when you write this reason, it will mean that because of this reason, it means that CF is going to become FD, also OF is going to be perpendicular to what? To CD, because of this reason. Okay? So this reason covers the fact that this angle here is going to be 90 degrees. And also because if the line originates from the center of a circle, it is going to pass through the midpoint of a chord, then it bisects the chord, therefore it will be perpendicular to that chord. Okay? So then from here, then you can say therefore OF, okay, is perpendicular. OF is perpendicular to CD. Okay? Which means now I have a right angle triangle which I can call OFD. Then I can use the theorem of what? Pythagoras. Okay? So this is 8.2.1. So I'll carry on here. So I'll say in triangle OFD, okay, I want OD. But do I have OF? It's given as what? 3 centimeters. So it's easy now because I know that FD, okay, FD is going to be half of CD, but CD is 8. Okay? Don't worry, I'm not coming. So I'll just say here, FD is equal to half of CD. So that's a half times 8, and you get what? 4 centimeters. Okay? I'm not done. I've only found the length of FD. I know that OF is 3, so I can get OD. So I'll say OD squared is going to be equal to OF squared plus GF or FD squared. And here you must write the reason, it's because of the theorem of Pythagoras. Then your OD squared is the one you want. Your OF is given as 3, so that's 3 squared plus GF is 4, I got it on top there, so you get 25 here, which means your OD is going to be 5 centimeters. And then you are done. So that's the first part. Okay? Make sure you memorize this is the converse of theorem 1. Line from center to midpoint of chord. Line from center to midpoint of chord. Right? Right, let's move on to AB. Now we are now along AB now. We need to calculate the length of it says hence. See this? Hence. Now this way the hence here means the answer that you got in the previous question, you need to use it to do this one. That's what the word hence means. From the result you got in the previous question, use that to get this question. Now, generally, geometry questions have a connection. What you do at the beginning is very important because you may need that answer to do something at the bottom. So if you get your radius wrong here, you're going to get AB wrong. Remember, your OD is a radius because this is the center and that point there is on the circumference. So OD is a what? Is a radius. Can you stop that? Can you put your phone away for a while? Put your phone away for a while. I have the theorem so I can see. Put your phone away. Okay? So we are going to need that radius. Now we want to calculate which length? The length of AB. Okay? So to do that, there is a construction which you have to do here. You have to construct a line. Okay? Either you can join point A to point O, or you can join point B to point O. And then you can decide now which of these two triangles, that is BEO or OEA, is the one that you are going to use to get the length of EA or BE. You can't get AB direct without getting BE or EA. Okay? You can't, it's not possible. Okay? You have to get either EA or you have to get BE first. Then you use theorem 1 to say that BE is half of AB. Why? Line from center perpendicular to chord. Okay? So first thing here, I'm going to identify my triangle. But the thing is, okay, I know that this is 5. Okay? Do I know the length from here to there? I don't know. Okay? I don't know. I don't know what this length is going to be. Okay? Let's look at the question. We have got OE, it's 4 centimeters, so we have got it there. So it becomes easy. Okay? So OE is what? It's 4. Now that makes things very easy because it means this is 5, that's 4. Okay? So if I choose triangle AOE, I can get AE using the theorem of Pythagoras. So that's what I'm going to do. So I'll get AE first. After getting AE, then I can get AB. The objective is to get AB. Okay? So the next step, so I'm going to do on the next page, is to say in triangle AOE, Okay, this is 8.2.2. In triangle AOE, okay, it will be AO squared is going to be EO squared plus, that's EO plus AE squared. And then you write your reason Pythagoras. Don't forget to write the reason, because sometimes we can give a mark for that. So, what is my AO? My AO is 5. So I'll put 5 squared here. My EO is 4 squared. I want to get AE first. Okay, so this gives me 25, and that gives me 16. If I take that, I'll get 9 equal to AE squared. So AE is going to be 3 centimeters. Okay? Right? Now I found AE. But how is AE connected to AB? That's where the theorem 1 comes in. Okay? So here I'll say, but AB is equal to 2 times AE. And this is because line from center, perpendicular to chord. You don't have to write bisect the chord or what. You stop there. If you've been practicing, you need to get familiar with the acceptable reasons in examination guidelines. Okay? So, once you get here, it becomes a piece of cake. Therefore, AB is equal to 2 times 3, which is 6 centimeters. Okay? Then we are done. Right. Now, if you do it this way, you get your full marks in this way. Okay? And this is not going away. Next year is going to come back in geometry. Sacred geometry is a very important topic. Okay, so this is an example on Theorem 1. Okay, Theorem 1. You don't have to get confused by anything. Right? This example, I've explained all the things you need. The difference between the original theorem and the converse. Okay? If there's a 90-degree angle, is the original theorem. If there's a chord which has been bisected, there's no 90-degree angle, you use the converse. Okay? Make sure you are very careful there. Alright? Any question? And then, so this is for theorem 1. This one here, the converse. Converse of theorem 1. Okay. So before you go to bed, you memorize that. Okay? If the chord is bisected, you must remember that, okay, I'm supposed to use the converse. The 90-degree angle won't be there. Right? If the 90-degree angle is there, then it's the original theorem 1. Okay, make sure you're aware of that. Alright? Do we have a center in the question? Yes. Yeah. Now, the fact that we have got a center here is a clue to you that somehow one of the 3 center theorems has to be used in this question. Okay? You check for the center first. Is the center there in the diagram? If it's there, it means one of the 3 theorems must be used on center. Either it's line from center perpendicular to a chord, bisects the chord, or its angle at the center is 2 times the angle at the circumference, or it can be angle in a semicircle. Any one of those 3. Then you can then eliminate based on your understanding of the 3 theorems which one is the appropriate one. Okay? Then, do we have a tangent? Yes. It's there. It means that means one of the 3 tangent theorems must be used. Tangents from a common point, we can't use it because we don't have 2 tangents. Which means either it's tangent perpendicular to a diameter or tangent perpendicular to a radius. Do we have a radius in the question? It's there. So you can use tan perpendicular to radius or the tan chord theorem. So two tangent theorems can be used. Do we have a cyclic quad? 4 points on the circumference. Okay, we have got point D, point C, point B, point A. Now, that should be a clue to you. Okay, then I need to use one of the cyclic quad theorems. Angles in the same segment, opposite angles of a cyclic quad add up to 180, or exterior angle of a cyclic quad. Any one of those what? 3 cyclic quad theorems. That's how you should approach the questions. Don't be intimidated by the diagram. The diagram should not scare you. Ask yourself, do I have a center? Do I have a cyclic quad? Do I have tangents? And then you eliminate each of the groups of what? Theorems based on the given diagram. So, BDC. Now, your BDC, we have BDC. It's this angle. It's inside the triangle BCD. Okay? So, to get this angle, we are told that CD is equal to BC, which means that triangle is probably isosceles. But you don't give isosceles as a reason. The reason angles opposite equal sides or sides opposite equal angles. Those are the two reasons. But here we are dealing with angles. So, there is a connection now. We have got this angle here, which is D1. It's equal to 40 degrees. But there is a chord CD, okay? Which means we have to use the tan chord theorem. So we have an angle between a tangent and a chord. This chord subtends B1. So B1 is going to be 40 degrees because of the tan chord theorem. Okay? So the first thing that I'll write here is to say B1 is going to be equal to D1, and both are equal to 40 degrees. The reason, tan chord theorem. Okay? Then, how is B1 connected to D2? Because our D2 is the BDC. Okay? It will be angles opposite equal sides. Okay? So I can write here, but CD is equal to BC. This is given. Okay? Then I can say, therefore, angle, okay, I've already written, then, therefore, angle B1 is equal to D2. Let me just write the given. It's equal to BDC, which means that's equal to 40 degrees. My reason is angles opposite equal sides. Okay? Exactly. Then you are done. For this question, now 1 mark will be given for the first part, statement reason, then the other mark for the answer with the reason. Or they might neglect the reason and give you mark for the answer that for 40 degrees. But the first part, which says tan chord theorem, that's important. Okay. Now, generally, the questions have got a connection. Whatever you get in the first part of the question, you need that in the question at the bottom. So I found BDC. The next question says angle C. Now, the angle C is this angle. Okay? How can you get that? Sum of angles in a what? In a triangle. Right? So we'll say 7.22. It's 1 mark. Okay? But you must write your reason. So we'll just say angle C is equal to 180 degrees minus 2 times 40 degrees. And our reason here we say sum of angles in a triangle. Okay, so angle C will be equal to 110 degrees. No. 100. It will be 100. It will be 100 degrees. Okay, and then you are done. Okay? No need to be scared by the diagram. Identify your three groups of theorems when you are given any diagram. And then from there you can carry on. Okay? When you see the diagram should not scare you. You must ask yourself, based on the three groups of theorems, which ones can I use to answer this question? That should be where you should start from. Right, then 7.23, we want to get angle A. How can you get angle A? How can you get angle A?
Say that A has equal to 180.
Why? Opposite angles of a cyclic path. Okay? So let's go to the next page. So we say A. So 7.2.3, we say angle A is equal to 180 degrees minus angle C. The reason opposite angles of cyclic path. Okay? So angle A is going to be 180 degrees minus 100 because we got C. So you get 80 degrees. Okay, it's 1 mark, so here they might give a mark for both the answer and the reason, or they might give for the answer only. Okay? It's angle C. So this is angle C. The pen. Okay? It's not very difficult. If you have got a positive attitude, okay, you know your theorems, and from what I'm telling you, you should make things easier. Identify if there's a center. Identify if there's a cyclic path. Identify if there's a tangent. Then from there you can then move on. Right? Then O1. Right? O1 is this angle. Okay? Now, is O1 2 times C or is it 2 times A? It's 2 times A. Okay? The other angle which you can call O2, it's a reflex angle, so it would make sense that it will be 2 times C. Because C is an obtuse angle. So O1 is 2 times angle A. And your reason, angle at the center is 2 times angle at the circumference. Okay? So 7.2.4, right? We want O1. So O1 is equal to 2 times A, and the reason angle at center is equal to 2 times angle at circumference. Okay, but what is A? Your A is equal to 80 degrees. So O1 is going to be 160 degrees. Okay, so this is what you are supposed to do tonight. You don't have to be scared of the diagram. Okay? Identify your three groups of theorems in the diagram. And then from there now, carry on. If you use that strategy and you know your theorems, you shouldn't have any problems. Okay? Any question? The last part. To prove that a tangent, okay, to prove that a line is a tangent. Okay? Now, when you are asked to prove that a line is a tangent, there are two ways of doing it. Either you can prove that the angle between a tangent and the radius is equal to 90 degrees. If you do that, then you can say, therefore, this line is a tangent. Your reason will be converse, tan perpendicular to radius. Okay? Or you can use the converse of the tan-chord theorem. If an angle is like, if you are given a circle Sometimes they won't give you a circle, like in this case, you don't have a circle, right? If you are given, say, a triangle like this, for example, and then this point is A, that's B, that's C. If they ask you to prove that, say, this is D, that's E, prove that DE is a tangent, it means you can either prove that this angle is equal to that, or you can prove that this angle is equal to that. If that is true, then you can say, therefore, this line, in this case, will be DE is a tangent because of the converse of the time chord theorem. So let's do this question. Okay? The question says AQ is a tangent to the circle in Q, and QP is parallel to AR. Okay? Prove that RA is a tangent to circle ABQ. Now ABQ is this. This is A, that's B, that's Q. It's a circle. What does that mean? The circle is not drawn, but it is a circle because these 3 points, if you draw a circle around them, they will be on the what? On the circumference. That's what this means. Circle ABQ means that point B, Q, and A will be on the circumference. The circle is not drawn, but it can be drawn in such a way that point A, B, and Q will be on the circumference. So the question is, prove that AR is a tangent. To what? To a circle which passes through point A, point B, point Q. Now to do that, it's not that complicated. In most cases, you have to identify an angle such that it's equal to this angle, but it can only be equal to this angle via this angle. Okay? And that angle is a third angle such that it will be equal to both these two. Okay? So it's more like you say x is equal to z, like this. X is equal to z, but x is equal to y, therefore y is equal to z. Okay? So there's an angle which is going to be equal to both these two, this one and that one, but this angle must be equal to something else probably inside the circle. If I'm to prove that AR is a tangent, what it means that this angle must be equal to that. But how are they equal? Okay, we have two lines that are parallel, that is QP and AR. This angle is equal to that angle. Why? Alternate angles. Okay, so I'm going to write here that angle A, okay, based on my diagram, I'll just call it PAR. Okay, PAR is equal to angle P. My reason, alternate angles. Alternate angles, then you must state the lines that are parallel. That is, QP is parallel to AR. Okay? That's where you start. Then, one of these two angles is equal to Q2. Okay? And it can be, at this stage, it can be this angle. Because we need to prove that this one is equal to that. So at this stage, we can't say that these two are equal unless we prove that Q2 is equal to P. If we prove that Q2 is equal to P, it means that Q2 is going to be equal to this angle because these two are equal. Okay? So PAR is this angle. It's equal to angle P because they are alternate angles. Okay? Then we need to prove that Q2 is equal to P. That's very straightforward. Because this is a tangent. Okay? This is a tangent. This is a chord. It therefore means that this angle is going to be equal to angle P. And that's Chord theorem. Okay? So we'll say Q2 is equal to angle P. The reason, Chord theorem. Okay? Once you do that, then you can say therefore, here, therefore, angle Q2 is equal to angle PAR. Okay? This should cause us to end up making a conclusion that hence AR is a tangent, Y converse Chord theorem. So from here, okay, I want to just complete it on the same page, so I'm going to move on to the topic. So I'll say, therefore, AR is a tangent. My reason, converse Chord theorem. Okay? So whenever you are proving that a line is a tangent, the sequence should all be like this when you are dealing with the converse of the Chord theorem. Remember, based on our theorems, the Chord theorem is theorem 9, theorem 9. Okay? So on is theorem 9. Right? Or if you can prove that a radius and a line are perpendicular, then you can say therefore the line is a tangent. But in most cases, it's the converse of the Chord theorem which you use to prove that a line is a tangent. Okay?